Hi dear students, welcome to my YouTube channel. Today we're going to start a Cambridge AS level mathematics past paper October November 2025. Code is 9709 and paper 41. This is mechanics 1 and paper 4. Okay, question number 1. Question number 1 is a car of mass 900 kilogram is moving along a straight horizontal against the constant resistance. Now this is given that there is a constant resistance and the mass of the car is 900 kilogram and the resistive force is 350 Newton. At an instant when the car is moving with the speed of 15 meters per second, the acceleration of the car is 0.25 meters per second square. Find the driving force of the car engine at this instant. And we want to find the driving force. Okay. We know that there are how many forces are acting on the car when car is moving at this instant. There are the two forces. The first one is driving force, which is pulling the car forward, and this will be the driving force. And there will be another force, which will be the resistive force. It will act opposite to the motion, and there will be FR, resistive force here. Okay. So then there will be on the mass of the car, which will be acting downward and the normal reaction upward. Okay, we have to write here the formula for driving force minus the resistive force is equals to, using the Newton's second law of motion, there will be ma, mass of the car times acceleration of the car. Okay, FD, we want to find the driving force here. Resistive force is given, which is 350 Newton. And the mass of the car is 900 kilogram times the acceleration, which is 0.25. And we can find the driving force by just shifting this 350 on the right hand side. It will be 350 plus 900 times 0.25. Okay, now we can use our calculator here. It will be 350 plus 900 times 0.25, and it will be 575 Newton. This will be the driving force acting on the car at this instant. Okay, part B is the power of the car engine at this instant, and we know that how can we find the power of the car? Power is equals to driving force times the velocity of the car. Okay, power is equals to driving force we found in the previous part is 575 times the velocity of the car, which is given here 15 meters per second. We can just multiply with 15 and we will get the answer. The answer will be times 15. It will be 8,625 watt. This will be the power of the engine at this instant. Okay, next question is question number 2. The two particles P and Q of mass 3. There are the two particles on the horizontal ground given here. This particle is P and this is Q here. The mass of P is given here, which is 3 kg, and the mass of the Q is 5 kg respectively. At rest, initially they are at the rest on the horizontal smooth. P is projected vertically, with the speed of 4 meters per second toward the Q. And after collision, after some time, there will be collision here, there will be Q here, and P here, there will be collision. And now the speed of P will becomes 1 meter per second. Find the two possible speed of the Q after collision. Okay, we want to find the speed of Q after collision, and we know that law of conservation of momentum, law of conservation, the velocity, not velocity, the momentum before collision, law of conservation of momentum is equals to before collision is equals to the after collision. This will be the law of conservation of momentum, and momentum is represented by P here. I can just say momentum before collision is equal to the momentum after collision. Okay, how can we find momentum? Momentum is actually the product of mass and velocity. So the mass of P is 3 kilogram here. What will be the momentum before collision? It will be 3 times 4 velocity multiplied by mass. This will be the momentum, but the Q is at rest initially, so 0 is velocity and the mass is 5 kilogram is equals to after collision. Okay, after collision, the speed of V is 1, P is 1 here, and the mass will be same, plus the mass of Q will remain same here, but we want to find the velocity. I can just say velocity V. So we can just calculate it. 3 4 12 plus 0 is equals to 3 plus 5V. Here 12 minus 3 is equals to 5V. So V is equals to 12 minus 3, it will be 9 divided by 5. You can again use your calculator to write the answer in decimal form. You can just leave the answer in fraction form, but 9 divided by 5, it will be 1.8. I can just write here 1.8 meters per second. This will be the velocity of Q after collision. Okay, next part is, it is given that lambda J of the kinetic energy where lambda is greater than 0 is lost during the collision. Find the value of the lambda. Okay, lambda is actually, what is lambda here? Lambda is change in kinetic energy. How can we find the change in kinetic energy? Okay, the kinetic energy before collision, Ke, I can just say before collision is equals to minus kinetic energy after collision. Okay, and we want to, what is lambda J is a kinetic energy. The lambda is lost during the collision. Okay, now we can see here the particle P is colliding with the particle Q here. Okay. Now the kinetic energy before collision, it will be 1/2 times mass of P, which will be 3 here, times the velocity. Velocity is force here. But in case of Q is at rest, so the kinetic energy of Q will be, you can say 0 here, minus the kinetic energy after collision. After collision, there will be 1/2 times 3. After collision, the velocity of P is 1 here. You can just write 1 square, plus the kinetic energy of Q, it will be 1/2 times mass of Q is given here, which is 5. So 5 times the velocity after Q is 1.8 after collision. This is the velocity after collision. You can calculate it. It will be for the 16 divided by 2, it will be 8. 8 times 3, it will be 24 here. Minus, there will be 3/2 plus, there will be V square, 1.8 square. So I can just write 5 times 1.8 square over 2. Again, I can use my calculator for this calculation. Okay, I can just write 24 minus, there will be 3/2, 3/2. Then there will be plus 5 times 1.8 square. The denominator, there is 2. Okay, I can just press equals to 7205. It will be 14.4. This is energy, so the unit of energy is joule. This will be the change in kinetic energy, and we can say this will be lambda, the change in kinetic energy. Okay, this was question number 2. Question number 3. Question is, the coplanar forces of magnitude 45 Newton, 28 Newton, and 72 Newton, and 35 Newton act as a point in the direction shown. Okay, find either order to the magnitude in the direction of the resultant force. And you can see here, these are the forces, and we can just resolve these forces into their perpendicular component. There will be, these are the two perpendicular components of 28 Newton. Similarly, the perpendicular component of this force will be this, and there will be a perpendicular component like these. These are the resolution of force, and now we can just see here what will be this angle. The rest of the angle are given here. We want to find this angle. There is a straight line, and if we subtract these two angles from the 180, because we know that the straight line angle is 180, so 180 minus 70 and minus 50, it will be 60 degree. So this angle will be 60 degree. Now we can write the perpendicular component here. This is 35 Newton force, and this is the adjacent of this angle 60 degree, so it will be 35. Adjacent will be cos 60 degree. Okay, what will be this perpendicular component? It will be 35 opposite of the angle, so sine 30. 35 sine 60. Similarly, you can see there 50 degree angle, and this is opposite, and 72 force is 72, and opposite it will be sine 50. This is adjacent here, so it will be 72 cos of 50. Okay, similarly we can write the rest of these two forces as well. This is vertical component, and opposite to the theta 35, so 28 of sine 35 degree, and this will be the last component. It will be 28 cos of 35. This is just the resolution of forces. Now we want to find the magnitude, and we know that how can we find the magnitude? First we need to find the resultant forces, the forces along x-axis and the forces along y-axis. So I'm just considering here Rx are the x component of the resultant force. It will be the forces that are acting rightward minus the forces acting in the leftward. So you can see from the diagram here the rightward forces. This is the rightward force is 28. We can say 28 cos of 35. This is rightward force. 28 cos of 35, and there is another force 72 cos 50 here. Again, I can just write here 72 cos 50. These are the two rightward forces. Similarly, you can see here the leftward force is only 35 cos of 60. We can just subtract this because it's the leftward force. So 35 cos of 60. I can just calculate this to find the resultant force of along x-axis. I can just use my calculator here. Again, 28 times cos of 35 plus 72 times cos of 50. Similarly, minus 35 times cos of 60. And it will be 51.716. I can write 51.72, or x is equal to 51.72. Similarly, we can find the Ry, the upward forces minus the downward forces. You can see there is a 45 degree force upward here, and there is another force which is upward 28 sine of 35, this force. So there will be plus 28 sine of 35. And there are two downward forces, minus 35 sine 60, sine of 60, minus there is another downward force 72 sine of 50. Now again we can use our calculator to calculate these values. Okay, here is 45 plus 28 times sine of 35 minus 35 times sine of 60 and minus 72 times sine of 50. And it will be 24.41. Ry is equals to back downward 24.41. Okay, this is vertical component. Now we want to find the resultant force, and the resultant magnitude of resultant force will be the horizontal component square plus the vertical component square and square root by using Pythagoras theorem, because Rx and Ry are perpendicular to each other. So there will be 51.72 square plus negative 24.41 square and whole square root. Again, we can just take the square of the y component plus 51.72 square, and it will be 3270. We can just take the square root of answer. It is 57.2. So the resultant is 50. What will be the answer? 57.2. This will be the resultant of the force. Okay, the next part is we want to find the direction. Direction is actually theta. So how can we find theta? Tan inverse rise is Ry, run is Rx. So here theta will be equals to tan inverse of 24.41 or 51.72. Different tan, it will be tan inverse, and there are 24.41 over 51.72, and it will be 25.3 along the positive x-axis. This will be 25.3 degree. Okay, question number 4 is two particles A and B of masses m kilogram and 3 kilogram respectively are connected with a light extensible string. Particle B is on the fixed plane. Okay, this is on fixed plane given here, which is at the angle of sine inverse 0.6, which is mentioned in the figure as well. Okay, the string passes over a smooth pulley. So the pulley in the given figure is smooth here. The particle A hangs vertically below the pulley, and you can see here at A is hanging below the pulley, and 0.75 above the ground, which is given here again, the distance from the ground. Okay, the system is released from the rest. In the subsequent motion, B moves up. It means that B is moving upward. When we release the system, okay, plane does not reach to the pulley. Okay, as B moves up the plane, there is a constant resistance of its motion. There is a resistive force which will be acting in this direction, 10 over 3. This is a resistive force. Okay, speed of A immediately before hitting the ground is 2. When this particle is moving downward, its speed before colliding to the ground, it will be 2 meters per second here. Use the energy method to find the value of B here. We can see here what we can do using the energy method. Energy method is actually when this particle is moving upward and this is moving downward, there will be a change in kinetic energy and a change in potential energy here, and we can find the difference. And there is one of mgh, which mass is m times g times h. H is given, which is 0.75. Okay, similarly, the potential energy of B, what will be the potential energy of B? Change in potential energy. We need to find the height, change in height. And you can see here, there will be a right angle triangle, and at this point, there will be a sine inverse. The similar angle will be here. So the distance covered by B, it will be 0.75 because this is attached with this inextensible string. So if we want to find opposite, we know that. How can we find opposite? Opposite will be equals to sine inverse 0.6 is equals to, we want to find the height of change in altitude of B over hypotenuse is 0.75. So height is equals to sine inverse is cancelled with sine, so there will be 0.6 times 0.75, the height of the B. So here will be mass of B is given here, which is 3 times h mg, and h will be equals to 0.6 times 0.75. This will be change in potential energy of A to B. Okay, similarly, we can find the change in kinetic energy. So change in kinetic energy will be equals to kinetic energy of B, and it will be 1 by 2. Mass is 3 times V. The velocity of this is given here. What is the velocity? It was given in the question. And you can see here the velocity of A. It was given, I think so. You can search from the question. Velocity is 2 meters per second. Because both particles are attached with the string, so the particle, the velocity will be same here, 2 square, minus the velocity change in potential energy, kinetic energy of A. So its mass is 1 by 2m times the velocity is 2. Okay. This will be the change in kinetic energy. To the 4, 4, 3, 12, 12 divided by 2, it will be 6 minus 2m. This will be change in kinetic energy. Similarly, we can find the work done by the resistive force. So work done by a resistive force Fr. This is given here. The resistive force is given 10/3 times the distance traveled by the particle. It will be 0.75. This will be the work done by. So now we can see here the change in kinetic energy. Change in kinetic energy is equals to change in potential energy minus the work done by a resistive force. So change in kinetic energy is 6 minus 2m is equals to the change in potential energy. It will be mg times 0.75 minus 3g into 0.6 times 0.75 minus work done, which is 10/3 times 0.75. From this equation, we can separate the m. So I can just use my calculator to calculate it. So there will be m. There is 2m, and we can just separate the m. Fit its big calculation here. I can get that answer, which is 4 kilogram. Okay, this is the mass. It is particle P of the mass m kilogram is in equilibrium here. Rough plane, the plane is rough here, inclined with theta to the horizontal. The equilibrium of P is maintained at the force of magnitude 8 mg Newton, making an angle with the theta with the line of the greater slope. The coefficient of fraction between P and the plane is 0.5 here. So okay, we want to find the theta. First we need to just see here what will be here. Weight. The weight will be mg. Its mass is given with it, which is m. So force weight will be mg. We can just resolve in the perpendicular component here again. There will be the two component. This component will be equals to mg sine theta, and this will be mg. No, this will be adjacent, so there will be mg cos theta, and this will be mg sine theta. Similarly, we can draw it more proper form, perpendicular to the plane, and there will be the horizontal to the plane. So this will be 8 mg. The opposite to the theta, there will be sine of theta, and this will be 8 mg cos of theta, which is adjacent to the theta. Okay, this is actually the resolution of these forces. So there is a resistor force as well, and we want to find theta. There will be a normal reaction part here, and it is vertical to the plane. And we can see here how there isn't any vertical motion here. So we can just write here R, which is upward forces, is equals to downward, because this is in equilibrium. So R is equals to, this is upward force, is equals to downward. We can see here there are two downward forces. The first one is 8 mg sine theta, and the other one is this mg cos theta plus mg cos of theta. And this was, you can say that upward is equals to downward. Similarly, we can see here there are rightward minus leftward. You can see here the rightward forces. There is 8 mg cos of theta acting rightward, and there is any other rightward force. There isn't any other rightward force. And if the particle is moving, trying to move downward, so there are the two leftward forces. You can say mu r. Mu is given here, which is 0.5 times r, and there will be a negative sign here because they are moving leftward. So another force is mg sine theta. So I can just write it mg sine of theta equals to 0. And we can just solve these two equations by just substitution method here. R is given here. We can just substitute here R and calculate it. So 8 mg cos of theta minus 0.5 r. R is 8 mg sine theta plus mg cos of theta. This what R is, minus the last term, which is mg of sine theta equals to 0. Now we can see here mg is in all the terms. We can just divide on mg to each terms, and we will get here now 8 cos theta. Change the color of the pen. It will be 8 cos theta minus 0.5 sine theta and minus 0.5 cos theta minus sine theta equals to 0. Okay, we can just see here cos theta minus 8 minus 0.5, it will be 7.5 cos theta minus, there is 0.5 sine theta and 1 sine theta here. There will not be 1 here. There will be actually 0.5 sine theta. There will be 8 here. 8 times 0.5, it will be 4. I have to write here 4. Sine theta minus 1 sine theta. This negative and negative, it will become positive. So there will be 3 sine of theta equals to 0. Now we can just shift this 3 sine theta on the right hand side, and we will get cos theta is equals to 3 of sine theta. Now we make that, so cos theta, divide both sides by cos theta, we will get and divide on 3. So there will be tan of theta is equal to 7.5 over 3. So theta is equal to tan inverse 7.5 over 3. Okay, we can use our calculator here. So tan inverse 7.5 b, and it will be 68.2. 68.2 degree. This will be the theta here. Okay. Question number 6. A particle A of mass 2.5 kilogram is released from the rest. So there are two particles on the smooth plane at the top of the plane. Okay, there are two particles, and I can say the top of the plane is particle A of mass 2 but released from the rest. So it is actually A here, and its mass is 2.5, and it makes an angle here with the horizontal. The angle is at sine inverse of 0.2. Okay, with the horizontal. Particle A is collide 2 seconds later with particle B of the mass 3 kilogram, which is moving upward. So here is another particle, which is B of the mass 3 kilogram. Okay, so it is moving upward with the velocity of 3.5 meter per second. Immediately after the collision with the B velocity, after collision, it will move downward with the velocity of 0.5 meter per second down to the plane. Find the distance A, and A is moving upward after collision. We want to find the distance here. This is covered by A, upward. Okay, so what we can do, first we can just see here there is a weight. We can just convert in horizontal component. Its weight is 2.5 g. It will be 2.5 g. There will be cos of sine inverse 0.2 adjacent, and the opposite is 2.5 g. Sine is cancelled with sine inverse, so it will be only 0.2 here. Similarly, you can convert. What we can do, the first step is we can just see here this particle A is at the smooth plane. It's given in the question. The force is acting on this part. Particle A is 2.5 g times 0.2, the force which is acting downward, and there is only force, and the normal reaction is cancelled with this component, so there is equals to 2.5 m acceleration. First we can just find the acceleration of particle A, then we can find the velocity before the collision, velocity of A before the collision, then we can apply the law of conservation of momentum here. Okay, so the A is equals to 2.5 g times 0.2 over 2.5. Can you calculate again? Find this calculation. So 2.5 times 10 times 0.2 divided by 2.5. It will be 2. So acceleration of A is equal to 2. Okay. Okay, 2 meters per second. Now we can find the velocity before the collision. The velocity before collision, it will be, by using first equation, V is equals to U is initial velocity plus A t. A is this, and t is given in the question, which is 2 seconds. So the velocity before the collision is 4 meters per second. Velocity of A, now we have the velocity of A before collision, velocity of B before collision, and we can now apply the law of conservation of momentum. It is before collision, so the mass of A is 2.5 times the velocity of A before collision is 4, plus the mass of B, which is 3 times the velocity before the collision, it was 3.5, and now the velocity after collision. The velocity of B is 3 times 0.5 after collision, and it will be negative here because it is moving downward. Similarly, you can see here these particles are also moving to the opposite direction, so we can just say when it is moving upwards, its velocity is positive, and when it is moving downward, this velocity will be negative here. Okay, plus in case after collision, the mass of A will be as it is 2.5 times the velocity after collision. What will be the velocity after collision, and we want to find it, so we can just write here V. Now again, we can use our calculator to find the velocity, and it will be 2.5 times negative 4 plus 3 times 3.5, and there will become positive again, plus 3 times 0.5 over 2.5. Now we can calculate it by using our calculator. So 2.5 times negative 4 plus 3 times 3.5 plus 3 times 0.5 divided by 2.5. Its velocity is 0.8. So the velocity after collision, the velocity of A after collision is 0.8 meters per second, which is moving upward now. Okay, now we have the velocity, we have the acceleration, which is positive 2 here, but when it's moving backward, it becomes negative. And we have the initial velocity, and the final velocity will be 0 here. So we can apply the second law of motion, the second equation of motion, 2as is equals to v square minus u square. Now we have A, which is negative 2, and it is moving upward. We want to find the distance here. V will be 0, and the u is 0.8. Okay, now s is equals to negative 0.8 square over negative 4. So we can find s again 0.8 square. So 8 square divided by 4, it will be 0.16. So this is the distance covered by A after colliding. This was question number 6. Now question 7. Particle P is starting from the rest. No, particle P start from point O and moving in a straight line. The velocity is given here, which is V is equals to 1 over 3 times 2 times T. It will be 2T square. And then there will be 8 minus 3. Minus 8 minus 3, it will be negative 11T. And there will be plus 12. We can just simplify it further, and it will be 2 over 3T square minus 11 over 3T plus 4. We want to find acceleration at t is equals to 2. What we can do when we have the velocity, we want to find acceleration, and we know that velocity, derivative of velocity is actually equals to acceleration. So the derivative is 2 times 2. It will be 4 over 3t minus 11 over 3. This will be the derivative. Now we want to find at t is equals to 2 here. We can just substitute 2 here. So 4 over 3 times 2 minus 11 by 3. It will be 8. 8 minus 11. There will be 3 over 3, it will be negative 1 meter per second square. This will be the acceleration at t is equals to 2. And we can see here what is happening. The velocity is decreasing. Okay. Now part B is find the total distance traveled by 3 seconds of its motion. And we can see here at t it is given that 2t minus 3. We can just see here at what time the velocity is 0. So the velocity 0 2t minus 3 is equals to 0. So here will be t is equals to 3 over 2, it will be 1.5. So velocity is becoming 0 at t is equals to 1.5. So it may be looking like this. You can see, okay, up 4. And we want to find the distance. We want to find the total distance up to 3. And we need to find the distance of this part and the distance of this part. Up at this point, the time is 1.5. And we know that. How can we find the distance from the velocity? We need to integrate it. So distance is equal to, but there are the two parts of this area under the curve. So there are the two portions, 0 to 1.5. So the limit from 0 to 1.5 of integration, and we are then write this expression of the velocity, which is 2 over 3t square. And then there is minus 11 over 3t. And the last one is plus 4. We are integrating with respect to t. Similarly, we can just find the other portion of this curve. So its time is from 1.5 to 3. This is, you can say that the converting of time into portions, because 0 to 1.5 is positive and 1.5 to 3 is negative, and we want to find the total distance. We are just going to add these two terms. So again, 2 by 3t square minus 11 over 3t plus 4 into dt. We can just integrate it. By integration, this will be 2 over 9t cube minus 11 over 6t square plus 4t. This integration will be same in the other portion as well, but the limit is 1.5, 0 to 1.5, and the limit is from 1.5 to 3. But now we can just substitute it. So there will be the distance is equal to 2 over 9. And t cube here, we are just substituting here 1.5. So 1.5 cube minus 11 over 6 into 1.5 square plus 4 into 1.5. The lower limit is 0 here, and there is no need to put 0 because every term has t, so it will become 0. Plus the rest of the part will be 2 over 9 into 1.5, not 1.5, there will be the upper limit is 3, so there will be 3 cube minus 11 over 6 into 3 square plus 4 into 3 minus the lower limit, it will be 2 over 9 to 1.5 square minus 11 over 6, 1.5, there will be cube here, 1.5 square and plus 4 into 1.5. So this is, you can see, a long calculation, and just using directly my calculator to calculate it. 2 over 9, so it's 3.75 meter. This will be the distance determined by the p. It turns to O or not. We can see here what was the equation of the distance. The equation was 2 over 9t cube. 9t cube minus, there was 11 over 6t square plus 4t. This is our equation. So we want to find its returns to O or not. So we can just see this. So this will be 2 over 9t square minus 11 over 6t plus 4. It's a quadratic equation here. We can just check its discriminant is greater than 0 or less than 0. If the discriminant is less than 0, then it means that there isn't any real solution. So no real solution will be here. So it will not return. So first we need to check its discriminant. First we can just simplify it. LCM will be 18 here, so we can just multiply with 18. Have returned. For the simplification, there will be 4t square minus 33t plus 72. And we can now easily check the discriminant b square minus 4ac. So it will be b is negative 33 square minus 4 into a is 4 and c is 72. You can just calculate it. I'm using my calculator. 33 square minus 4 times 72. It is negative 68, which is less than 0. So it will not return to a. P will not return to. This was question number 7. Question number 8 is a block A of mass 2 kg and particle B of mass 0.5 kg. The mass of this is K1.5. Connect with the extensible string inclined to 0.9 to 15 degree to the horizontal. And acceleration is 1.2 here. The force of magnitude 6 Newton is acting upward on E, acting with 20 degree above the horizontal. Okay, and the question is find the tension in the string. So here will be the tension. We can see here there will be the two component, the horizontal component and the vertical component. Okay, there are the two forces. And this horizontal component, it will be T cos theta. Cos theta is 15 here, and there will be T sine theta. T sine theta will be cancelled with the normal reaction. There will be R here. So these two will be cancelled with each other. And there is the only horizontal component, T cos of 15. And the other force which is acting on this particle, it will be MA. Its mass is 0.5. And acceleration is given here, which is 1.2. So we can find T from here, 0.5 times 1.2 over cos of 15. So tension in the string, it will be 0.5 times 1.2 times divided by cos of 15. And it will be 0.621 Newton. This will be the tension in the string. This was part A. Find the coefficient of fraction between A and surface here. You can see this was under the B, there was the smooth surface, but under A, there is a rough surface here. And we can see here this direction. So 6 sine 20 plus RA, normal reaction of A, will be equals to 10 times 2 plus the other force which is acting downward is T sine 15. Here is we want to find what? Find the coefficient of, we want to find mu here. This is part of the one equation we have made is this. This is the vertical forces. Similarly, we can see the horizontal forces acting on this as well. 6 cos 20, which is acting leftward, and T cos 15 is also acting leftward. But when this is moving in this direction, there is another force where mu R will acting backward. So the forward forces are 6 sine 20, 6 sine 20, and 6 sine 20, 6 cos 20, 6 cos 20. And the other force is T sine, or T sine 15 acting backward, T cos 15, negative T cos of 15, minus the other force is mu R. Mu R. Motion and mass is 2, and acceleration is 2. It's given that acceleration is 1.2 Newton. So now we have these two equations and we can find the mu from here. First we have to find RA, then substitute this in this equation. So RA is equals to 10 to the 20 plus T sine 15. T is 0.621. And then sine of 15 minus T minus 6 sine of 20. This will be the normal reaction R. So we can use a calculator to calculate it. So 20 plus 0.621 sine of 15 minus, there is minus 6 sine of 20. It will be 18.12. It's a normal reaction. We can just substitute this R here to find mu. So 6 cos of 20 minus 0.t is 0.621 cos of 15, and can just shift this mu R on the right hand side, and 2 into 1.2 on the left hand side, we will get mu into R is 18.12. We can calculate mu from here. So it will be 6 cos of 20 minus 0.621 cos of 15, and then negative 2 times 1.2 divided by 18.12. Answer is mu is equals to 0.1456.